Can we hear Amanda, or is it just me?
How about now? Does that maybe fix it?
Oh,
all right, there we go.
Yeah, okay.
It's been a while.
Woo! Hello. This is the fun of doing it live. So here we go. Yes, welcome back to Dome to Home. My name's Rémy. I'm an astronomy student at CU Boulder, and I'm a presenter at Fiske Planetarium. And below me, we've got...
Hi, I'm Amanda. It's been a while since I've done a video with you guys, but I'm excited to jump back into it. As you've probably seen before, if you've seen me before, I'm a senior at CU Boulder, love navigating for Fiske, and I'm really excited to teach you guys about perseverance.
Yeah, awesome. So also helping us will be our question master and chat moderator there in the chat, Jeremy. So feel free to hop in, say hi to Jeremy. And while we're talking, if you have any questions or comments, let Jeremy know and we will answer them here live in the video. So today we will be continuing our Perseverance to Mars series by talking a little bit about planning the mission. So, what does it take to plan out and put together a big mission like this? And it turns out it takes quite a lot. So the path from deciding to put a rover on Mars to actually putting it there is no walk in the park. So the Mars 2020 mission, which carries our Perseverance rover, was announced all the way back in 2012, which was 8 years ago, in case you don't want to do the subtraction like me. So, the announcement came not long after sending our last rover, Curiosity, to Mars. In fact, Curiosity hadn't even landed on the planet by the time we had announced that we are going to be sending another rover. So they really think about these things really far in advance. After the announcement, what they do is they open it up for proposals from researchers around the world. Rovers carry a number of instruments. They don't all come from NASA. So the team wants to hear ideas from all over to choose what instruments to send. Once those are chosen, you can start working on building it, putting it together, shipping it to the launch site, and then we send it to Mars. So easy peasy. But then why did it take 8 years to get this all together, right? So a lot of that has to do with decision making and the lengthy process of actually building the complicated machinery involved in a huge mission like this. All the rovers have taken years to put together. Big missions like this take a long time because it takes a lot of people from a lot of agencies and institutions all working together to put together any rover mission to Mars. And I mean, a lot of people.
Maybe something like this entire group of people.
Let's count them. 1, 2, 3, 4, a lot.
A lot.
So, this is the team for the Mars 2020 mission. Everyone from project directors to interns posed here at NASA's Jet Propulsion Laboratory in California, and I'm sure there's more who couldn't make the photo. Researchers across the globe, they all came together to make this mission a reality over those 8 years and are continuing to work on making it a success as it makes its way to Mars right now. So from the time of the announcement, they know that JPL, Jet Propulsion Laboratory, will be the one making the rover. They've made the rovers in the past, they're making this one. But a number of other people are involved. First you have to choose what's called a science definition team. And their job is to determine like what kind of science we want the rover to do and what we're sending it there to learn. If we're just sending a rover over with absolutely no goal, then you don't really know what you're doing. So we have some people decide exactly what we want to do with it. So for Mars 2020, they chose 4 main science objectives. So the first one is to look for habitability, see if Mars was ever capable of supporting life, to seek out biosignatures, to see if life really did exist there, to cache samples of Martian rock and soil, so a future spacecraft can return the samples to Earth for further study, and then also to prepare for humans. And this is the first rover to actively work on this question, or this goal. So, with those main goals in mind, Mars 2020 team searches through all the proposals from research institutions around the world. But what the instruments do, is only part of the decision-making process. Designing a spacecraft, it's a lot more complicated than just what it does or looking cool or having a neat acronym, as fun as that is. For starters, we have to worry about things like budget constraints. It sounds really boring, but you do have to worry about money. These agencies don't have an unlimited budget to work with, and they're working on other projects at the same time. A mission like this, though, is considered, a flagship mission, which means, it's a big mission that gets a big allowance to do big science, but it's still not unlimited. I think we have some ideas of how much something like that costs.
Yeah, so we can start by looking at the overall federal budget.
So this is around the time that they had started planning this. So 2000, they announced it in December 2012. So here's 2013, what it looked like. You can see NASA is such a tiny sliver, you can barely see it. And then within NASA, you've got a lot of stuff they're doing. There's human space flight. So sending people to the International Space Station, for example, then technology research, and then boring stuff, like keeping the lights on and cleaning the building and stuff like that. So that science portion is what we have to work with. And the science isn't just these flagship missions. You've got a lot of other things that NASA works with. So you have to decide how large of a piece of that pie you want to, put towards sending a rover. And I think we have an idea of kind of a comparison of how much a rover might cost. Yeah. So a year of having Curiosity on Mars was $60 million. And then having one astronaut on the International Space Station for 1 week is about $49 million. So they're both pretty expensive, still a small slice of the pie, but you do get a lot more out of sending a rover to Mars, or bang for your buck, I suppose. But that's kind of the idea of what we're looking at for budgets. So it's kind of it's not the most exciting thing to worry about, to think about when we're talking about planning a whole mission to Mars, but it is one of the most important things to think about, because as much as we want to do everything, there's only so much we can work with. In addition to that, we also have to worry about whether or not it's even something we can realistically send. Of course, we have to make sure it's something that we can actually build within our time limits and actually can exist. But we also need to make sure it fits on the rover, that it fits with the mission, and that it doesn't weigh too much, because the more something weighs, the more difficult it is to send. So rockets can really only send so much weight up. That's why we need bigger and more expensive rockets with more fuel when we want to send more stuff. So the more compact an instrument is, the easier it's going to be to send. So, of course, we also want to make sure that the interest and utility is there. We can't send every single instrument proposal, unfortunately. So we like instruments that are versatile and will be as useful as possible. So they selected 7 instruments to put on the rover. And, oh, yeah, there they are. So these are the 7, big instruments that go here on the rover. We have some that take some really good pictures, and they see in different types of light. For example, X-rays and ultraviolet, infrared, things like that. And there are some that can tell us what the rocks and dirt are made out of. There's even one that's going to attempt to produce oxygen from the Martian atmosphere. And that's really important if you want to make rocket fuel for return missions or air debris if humans were to visit. It should be a really exciting experiment. It's one of the first ones that we've really done with future missions in mind, like sending people and coming back. If it works well, they can scale up that technology in the future. And that's the MOXIE one right there that I was talking about. So, in addition to the instruments on the rover, actually, we also have this little helicopter called Ingenuity that's going to fly around and take some pictures. I'm really excited about this because it's cute. I'm not going to lie. There's a lot of reasons to be excited about it. It's one of the first, powered flights on Mars. Up until now, the only flying things we've sent were just falling. They were falling with style, though, and isn't that what flying is? But this one should be really exciting. It'll just fly around and take some pictures.
And you can see how proud Perseverance is of Ingenuity. He looks up at him as he's flying around. They've got a good friendship.
They're doing fantastic. So, at this point, they've decided what they're going to build, and now comes actually building the machinery. So the rover design is actually very similar to Curiosity. Curiosity was a really well-designed rover, and basing it off of known designs does help a lot. Instead of starting from scratch, we've got a nice blueprint to follow and simply improve upon. So, instruments were decided by 2014 or so, and then it was followed by a lot of logistics and approvals and meetings and boring things before assembly began in January of 2018, actually at JPL's spacecraft assembly facility in California. And everything had to be built, assembled, ready to launch from Florida in July of 2020, July this year. So with that deadline in place, they begin their work building. So this facility is where JPL has been building spacecraft since the 70s, actually. So you may have seen pictures of some of these machines being built, and everyone's always wearing those like suits, those big white and blue suits. They're called bunny suits, actually. Whenever they're in the room. So they wear those to prevent, anything dirty from getting into the machinery. So these are like called clean rooms, because you just don't want anything on the equipment if you can help it. You don't want dust, you don't want hair, oils, particulates, anything like that, because these rovers need to be pristine for them to work well. Even the smallest particulate can interfere with electronics. And if we were to like get bacteria on it or any sort of microbial life, and we bring it with us to Mars and we're taking some readings, and then we find life and we're really excited, and it turns out it was just something we brought with the rover, that would be kind of unfortunate. And then you don't want to, accidentally infect Mars. So, keeping everything clean is essential. And that's a huge bonus to building it in this room. That's why we don't just build it wherever. So while the rover and some of the instruments are made there at JPL, some of the instruments are made at the institutions in charge of them and then shipped out upon completion. But everything needs to be done, tested, and ready a few months before the launch so that they can take the time to ship the equipment from California to Florida and then go through all the final tests and cleaning before launch.
And the crazy part about this is they're on a pretty strict deadline, aren't they, Rémy? Yeah. It's not like we can just, have something done here and have something done there. No, we've got an idea of when we need all this done, tested, cleaned, all of that for a very specific reason.
Absolutely. So the thing about space is that things are moving around. So you may have heard about the Earth moving around the sun, Mars moving around the sun, everything's moving around. So sometimes we're a lot closer to Mars than other times. And sometimes we're really far away. And what we want to do is make sure that we're getting the best trajectory, the best alignment out there. So here is, here's the trajectory we're looking at. So the blue is the Earth, the green is Mars, and then that pinkish purple fuchsia, I'm not sure what color you want to go with there, is the spacecraft. And you can see there it goes getting to Mars. So they really work to align things like that. So every few years you get something really good like that. And that's when they try to send missions to Mars. Actually, 3 missions were sent out this year because of that really nice alignment. So yeah, they want it to be as simple as possible. And in addition to the trajectory, we also have to decide where it's going to land. So in this case, scientists chose a former river delta in an area called Jezero Crater. There were more than 60 options that were proposed for a landing site, actually, before they decided on Jezero Crater. So Perseverance rover, the instruments, and our little Ingenuity helicopter, they were finished and shipped out by February of earlier this year, along with the Atlas rocket that would take it to space. And the trajectory and landing plans, they were sent far in advance. And at that point, it came down to, final testing and then the launch. So you have a launch window of a few weeks, and we were able to successfully launch it on July 30th of this year. Did anybody get to watch it? I didn't. I was busy.
That would have been neat, though.
It would have been neat. So, at this point, we've got it. Oh, is that Jezero Crater?
There it is. Yep.
Oh, awesome. So that's where we're headed with Perseverance. And that should be landing there in February of this year, I think the 18th, or not this year, next year, 2021. What is time? At this point, it's just a matter of everything going according to plan. And so far, it's been doing well. So keep an eye out, and we'll see what happens with Perseverance.
And in case you guys didn't get to see any of the launch, we were able to get a small clip. So let's go ahead and check that out too. It's got some cool shots of the rover before.
There we go. I love a good rocket launch. It just looks so exciting.
And it's really impressive too, just to know that this is something that we've been able to do for over 50 years, like over 75 years. We've been launching rockets into space, and it looks so cool, and it looks cool every time.
It really does. I'm excited every time I see that. So I want to make sure that we have time for any questions. If there's anything that I didn't cover that you're really curious about, or if there's just anything about the mission or about Mars or space in general that you have questions about, go ahead and drop them in the chat for Jeremy, and we'll talk about them right here, right now, live. But in the meantime, while we wait, we can talk about a few other common questions. One common question is, how is it powered? So a lot of rovers have different ways of being powered. For example, Opportunity was solar powered, which is why, unfortunately, it shut down after that big dust storm. The solar panels got covered there. So that was solar powered, which means it really only works as long as the sun's out. But both Curiosity and Perseverance work off of radiation. So plutonium is actually inside there. You've got a little less than 10 pounds of plutonium that are powering these ones. So it's just vaguely radioactive.
And another cool thing that we learned about this mission was that Mars 2020 is going to be the first rover that has a microphone on it. So there have been the InSight lander that landed not too long ago had a seismic microphone. And so it could hear what was happening on the inside of Mars through the vibrations. But Mars 2020 is actually going to have a microphone on it to just record the sounds of Mars. So if you've ever heard like Saturn's rings, or if you've ever heard flying through the Eagle Nebula, those sounds are kind of creepy. We kind of turn those vibrations into something that you can hear, just like InSight did, but this time we're actually going to get to directly hear what's going on Mars. So there probably won't be too much traffic or chatting, but it will be interesting to see what we get.
Instead of falling asleep to ocean sounds, you can fall asleep to the soft sounds of Mars. It looks like we have a couple of questions. Aurora would like to know, why haven't rovers been sent to other planets? So we have actually sent a couple of rovers to Venus, and by we, I mean the Soviet Union. They took pictures, but then they pretty much melted, disintegrated. It didn't work very well. Venus is a really, really tough planet to really land on. It's not very friendly. One of the main reasons we go to Mars is because, first off, it's a lot friendlier than Venus. You can see here, even the coloring from the Venera landers just looks like not a place I would want to go. Because Venus, which is really the closest planet to us, is just not very hospitable, which is why we just never sent anything back. It's really difficult to kind of make the cost worth it. I'm sure there are a lot of scientists who study Venus that would love to get a good lander on there. But Mars is just a really nice place to visit because it's still fairly close. There's a lot of evidence that there was life there. There's evidence that there was water there, which we talk about actually in a lot of our past videos as well, and we'll talk about in our future videos. That just makes Mars a really nice candidate. So it's just a matter of deciding what our priorities are. I would love if we could send like rovers to other planets. That'd be amazing, but again, there's budgets and being a little realistic. So hopefully in the future we'll be able to get things to other places. There are a couple of questions from Michelle. There's, would you ever consider traveling to Mars? I'd think about it. I definitely think about it because it seems really exciting, but it sounds like it would take a long time. Michelle's other question is, how long would the round trip to Mars take? So at current speeds, it's taking, let's see, July to August, September, October, November, December, January, February. It's like taking 7 months for Perseverance to get there. So 7 months to get there and then a pretty decent amount of time to come back. So you'd be gone for a pretty long time. I think that's my main hesitation to go. What about you?
Oh, I don't know. I always said that if I was, for whatever reason, offered a mission to go to Mars, that I would definitely take it. But then I think about things like, oh man, I couldn't go to my favorite restaurant, or, I couldn't have my cat with me, or just like little things. But I think I would go for it. I think I would.
Yeah.
Why not? It would be so cool.
I would
if you
miss
got to
some
come back,
food.
you'd have one heck of a story to tell.
That's true. I would be so obnoxious at parties. Did I tell you about the time I went to Mars? I do actually see a comment in the chat. SB was saying that they wish they'd majored in space exploration, relevant major, might go back to CU for redo. I just wanted to say that that's something that a lot of people do. I'm actually a non-traditional student myself. I'm headed back to university. So like Jeremy just said in the chat, you know, there's always time to go back and think about other options and things like that. So never let your set path be the one that you have to stick to. You can always jump around. I just wanted to comment on that because that's something that a lot of people don't really think about.
Absolutely. And even people who don't necessarily want to go back to school for it, there are so many awesome resources online, including Fiske Planetarium's YouTube, to learn about anything.
Fiske Planetarium's YouTube, you say? Tossing some self-promotion. So there's half a question on here from Mr. McFarland. Do the missions they? They could. If we get the rest of the question there, we can go ahead and answer that. Yeah, let's see. We can give just another couple, like a minute or two here for any other questions. One thing I found really interesting actually about the rover, we were wondering about this last night, is how fast the rover can move. Because when you think about, you know, rovers, you think about it going pretty fast because you drive in a car, you've ridden in a car or whatever, and you watch, they go really fast. But actually this rover goes about 0.1 miles an hour. You could like walk leisurely 30 times faster than the rover can go. But we do want to be cautious though when we're moving around and we're enjoying the view and taking samples. And actually compared to some of the other rovers, it's a speed demon. So don't underestimate it. We've got a question. 𝐀𝐜𝐭𝐢𝐯𝐢𝐭𝐢𝐯. I'm so sorry if I'm saying that wrong. Do you like Pluto? I do like Pluto. Pluto's really nice. It was really exciting when we got to get the pictures of Pluto because our old pictures of Pluto were just vague pixels before we got these really, really nice pictures right there. Thanks, Amanda. So it was really exciting to see something new like that. So we've got another question. So do missions get planned to avoid launches during the tropical storm season if the Atlantic, off the Atlantic seaboard, even if the window for the opposition of Mars and the Earth are during that time frame? So what's really lucky is that time frames aren't just like a couple of hours in one day. We've got a few weeks. So sometimes, and actually this did happen in, I think, at least 2 out of 3 of the Mars launches this summer had to be postponed because of weather and various other things. So that does happen where you end up with some really bad weather or tropical storm season, things like that, and you have to push back launches. But I don't think we've ever run into something where the entire few weeks were really bad weather and we had to just scrap the whole thing. But it is something that we really have to look out for. So they're always looking at the weather to make sure that it's going to be okay to launch a rocket. We've got a question from Alex who says, will Perseverance and Curiosity be able to meet each other? That would be really nice. I would love if they could, but they're in completely different places on Mars. When we, send landers and rovers, what we like to do is we like to make sure that we're covering as much of the surface as possible. If you were an alien trying to explore Earth and you sent a few rovers and you sent like one in Cincinnati, one in the Sahara Desert, and then you were trying to figure out another place and you said, well, I want them to meet. Let's send the other one to Cincinnati. You're missing out on a lot of the Earth, on a lot of the stuff that you could be learning. So we try to go to a lot of different places that we can learn as much as possible so that we can really get a good idea of all of Mars. Because although it looks like Mars is all the same, there's a lot of different stuff that was happening there. So for example, there's the river delta where we're going to be landing Perseverance. We've got, 𝐀𝐜𝐭𝐢𝐯𝐢𝐭𝐢𝐞 is Ileana and Brooklyn. They're sisters. Awesome. I'm glad you get to watch together. We've got another question following up on the weather. Do dust storms on Mars come into the timing of the launch plans? Or are they too unpredictable? So there's like seasons where they're more common, where you're more likely to run into a dust storm. But you can't really say exactly when they're going to happen, and you're really basing it more off the convenient launch window. So yeah, that's it. That's a really good question. It's something that they do think about. Ooh, I love these pictures. So these are like dust devils on Mars, like little baby tornadoes. Luckily, the wind on Mars, because the atmosphere is so thin, is not a lot. If you were caught in a huge windstorm, it wouldn't feel like much to you on Mars. The main issue that we run into with those is just getting things in the machinery, like getting dust in the machinery, or in the case of a solar-powered one, a solar-powered rover covering up the panels. So it's not a huge problem that we run into, as far as I'm aware. Amanda?
You know, I was just thinking that luckily the rovers themselves are incredibly heavy and usually a lot bigger than you think. So we wouldn't have to worry about it like tipping over or being knocked into a crater or anything like that. But yeah, Rémy's concerns are very valid of like, we just don't want any dust getting into any pieces of machinery, any cogs, you know, we don't want it to get stuck because of a rock that blew in front of its way or something like that. So usually I believe we'd be okay, but you know, there's the rare accident that can shut something down, unfortunately.
Yeah, unfortunately, space travel can be really, really unpredictable.
Dicey for sure.
Oh, third grade, that's awesome. I loved third grade. Yeah, I think unless there are any other questions, we could, how soon do you think humans will be colonizing Mars? Great question. So a lot of times there's the hopeful timetable and there's the realistic timetable. So, you know, there's always the hopeful timetable of we'll put someone on Mars by the end of the decade. And then there's kind of being a little more realistic. There's a lot of technology that we really need to like think about and get into. And I think the last video in our series is actually going to be called Preparing for Humans on Mars. So we'll be talking a little bit more about what it'll be like to send humans to Mars and what the future could be like with that. As far as actually colonizing Mars, I think that's a really long way off, far enough that I really couldn't think of a good answer in years there. What do you think, Amanda?
And I believe that we'd like to colonize the moon first, just because the moon is so much easier to leave from. So if, you know, if we wanted to send people, if we wanted to make 10 trips from the Earth to Mars, that takes a lot of fuel and a lot of money. Whereas if we made 10 trips from the moon to Mars, it would significantly reduce cost and resources and all that. And, you know, what better place than to start colonizing in somewhere that's way closer and that always stays close to us versus Mars, where we could be on opposite sides of the sun. So I would like to think that maybe we'd think about colonizing the moon first, which, you know, in itself is going to take so long. So a long time. Yeah, I agree with
a good long while. It'd be really cool though. I'd love to see it. Yeah. All right. So let's wrap it up. If there are any other questions that you want to ask, feel free to leave a comment on the YouTube video or email us, visit our website, and we can answer in the next video or answer your emails. But we had a lot of fun today. That's all the time we've got. Thank you so much for joining us. You know, I think we had a blast and I hope you were able to learn something new about our new Mars mission or about space in general. So be sure to come back in the following weeks to learn more about Mars and about the future steps in this mission. You know, next week we'll be talking about how the planet formed and changed with Tara, and Amanda will be back. So our full schedule is actually in the video description, so you can see what we'll be talking about any given week. And, you know, again, thanks for coming. Don't forget to like the video if you enjoyed it and share it with your friends, any friends who are interested in space. And if you want alerts for more videos like these, make sure to subscribe to the channel and be sure to have alerts turned on. Thanks so much for joining us. I hope you all have a good week.
Absolutely. See you guys next time.
Bye.